Hello everyone, a very good evening to each and everyone out there, and I welcome you all to this amazing platform of PW English class 9th and 10th and to your Phoenix batch. So as you all are aware about that, we are doing one shots of all the chapter in your NCERT, and hence today we are starting with the one shot of the chapter circles. So we are going to start with the introduction, the parts which are related to this chapter, the concepts, the theorems, the topics and the words that are really helpful in this lecture. So let's start by solving it. So the very first thing is what we are going to do in this particular lecture, the topics to be covered. So we are going to start with the introduction, what is the exterior and the exterior interior on the circle, arc, sector, segment, angle subtended by chord, theorems, perpendicular from the center, angle subtended by an arc of a circle, and some important questions related to this. So this chapter is really very easy if you think about it. It's the very powerful part of geometry, and this is important for your class 10th as well. So of course you need to have some basics clear. So we are going to start with, of course, the basics first of all. So let's learn about introduction. So what is a circle? We know. Everyone knows about what our circles look like. So basically, if we take a fixed center, and from this fixed center, if we take a fixed distance and we start plotting points, and if we start plotting points from this fixed center, the resultant image, this doesn't look like a circle, but yeah, of course it forms a circle if we have a fixed distance. So let's talk about the parts of circle. Right, we know what is a radius. Let's discuss about radius first of all. So whenever we know that we take a fixed distance, and from this fixed distance, if we draw a circle like this, right? So from the center of the circle to the circumference, this outer boundary is known as the circumference. The region enclosed by the circle is called the area. From the center of the circle to the periphery or to the circumference of the circle, this line which is formed is called the radius. This distance is the radius. And if we double this radius, this becomes the diameter of the circle. Right? So these are the basic parts of circle which you already know. Now let's talk about when we draw a circle on a plane. For example, I have drawn a circle on the previous slide. So how many parts that circle divides a plane into? That circle divides the plane into three parts. What are those three parts? Exterior of the circle, interior of the circle, and on the circle. Now again, let's talk about this with the cricket stadium. So of course we know that the boundary, let's take the boundary as circle of the cricket stadium. So that boundary is on the circle. If any ball lands on the boundary, that means a 6, of course, directly. So that means on the circle, all the people, all the visitors or the people who see the match, they are sitting outside the circle, and all the players are present inside the circle. So these are the three different parts in which a circle, if we draw a circle, it divides the plane into three parts: interior, exterior, and on the circle. Now let's talk about the very first thing, right? The arc of a circle. Now we know that the boundary of a circle is known as circumference of a circle. So when we talk about the circumference of a circle, that means the boundary of circle. And if we take a part from this circumference of a circle, it is called the arc of the circle. What a part means? For example, from here to here, if I take this part, right, this part. So what is arc? Arc is the part of the circumference of a circle. As simple as that, right? The next thing that we have is sector of a circle. Now whenever we talk about sector, we talk about pizza. So what is pizza? Basically, how is your pizza made? It's a circle, right? And what is a slice of pizza? A bite like this. Right? So basically, if we compare this with respect to circle, so sector means basically two radius and arc of a circle. If taken together, it forms the sector of circle. So whenever we look at a pizza and imagine it to be a circle, so when we cut it into slice, this part is the radius, this part is the radius, and this part is the arc of the circle. So sector is what? The shape of a sector somewhat looks like a slice of pizza. But you might be wondering, ma'am, if we take one slice of pizza, this part which is remaining now, if this is also sector of circle, yes. The smaller one, the smaller piece, if you'll ask a slice, I'll give you this slice. So for the smaller slice that we talk about, this becomes the minor sector. The bigger portion of the pizza we talk about, that becomes the major sector. So when we specifically talk about sector in terms of circle, so basically what is that, bacha? If I cut it into this part, so this part which is formed is known as the minor. This is the minor sector, and this part which is formed is of course the major sector of the circle. Clear till here? Now let's talk about segment. Now as we have discussed that sector is 2 radii and arc, similarly chord is formed by the segment is formed by a chord and the arc. So this is the chord of a circle, right? This is the arc of a circle. Whenever in a plane circle, if we draw a chord, it divides the circle into 2 parts, and that is segment. The smaller portion is known as the minor segment and the larger one is known as the major segment. The smaller one is minor, the larger one is major segment. Now let's talk about segment. So when we talk about segment, segment comprises of 2 different things. One is chord of a circle and the other one that we talk about is arc of a circle. When we talk about sector, so 2 radii of the circle, the plural of radius, and the arc of the circle forms your sector. Now the next thing that we have is, we have discussed certain things by now. Let's give it a quick recap for what we have done, right? Okay. So the first thing is, the longest chord of a circle is dash of the circle. So if we talk about chord of a circle, students, so what is chord of a circle? It is any line that starts from the circumference of the circle and ends at the circumference of the circle. So basically, this is a chord, this is a chord, this is a chord, this is a chord, this is a chord. So out of all these chords, which one will be the largest chord that passes through the center of the circle, or we can say it is the diameter of a circle. So diameter of a circle is the largest chord of the circle, the longest chord of a circle. An arc is a dash when it ends at the ends of a diameter. Now listen to this thing very carefully. This is a circle, right? Let's draw a diameter, basically a line that passes through the center of the circle. Now basically what the question says, this is an arc, a part of circle. If the arc starts from the starting point of diameter and it ends at the ending point of the diameter, so this becomes what? A semicircle. So what do we call this? This is known as a semicircle. Now let's move forward for the third part. Segment of a circle is the region between an arc and, so we know that when we talk about segment, bacha, so it is the region between the arc and the chord of a circle. So CHORD, chord, will be the correct answer for the question, right? Now the next thing that we have over here is, a circle divides the plane on which it lies in dash path. So we have already discussed this part relating to the stadium part. So basically, whenever there is a cricket stadium, the boundary is set up. There are 3 different parts, that is on the boundary, inside the boundary and outside the boundary. Getting it? So it divides the circle into 3 equal parts, 3 parts. So basically inside the circle, on the circle and outside the circle. So these are the 3 different parts that we talk about. The next we have is true and false. Line segment joining the center to any point of a circle is the radius of circle. So if there is a line segment joining the center to any point on the circle, of course it becomes what? The radii of the circle. So this statement is absolutely true statement. So this statement is what? This statement is your true statement. I hope this thing is clear with everyone. The next is, a circle has only finite number of chords. No. When we talk about circle and when we talk about chords, bacha, this is also a chord, 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 chord. All these are chords to the circle. So how many can you draw? Infinitely many. So a circle has finite number of chords. False. Finite means limited. Circle does not have limited number of chords. When we talk about circle, it has infinite number of chords, or we can say unlimited chords. The next that we have over here is, if a circle is divided into 3 equal arcs, each one is a major arc. Let's see. If this is a circle and if I divide these arcs into 3 parts, that means this part is equal, this part is equal and this part is equal. So 3 of them becomes the major one? No. All 3 of them becomes equal, or we can say the minor arc of the segment. Next, a chord of a circle which is twice as long as its radius is the diameter of circle. Of course, if the radius is doubled, if we double the radius, the chord that we will be getting will become what? It will be the diameter of the circle for sure. So this is again a true statement. Next thing that we have is angle subtended by a chord at any point. Now this is extremely important part of this chapter, like very important. If you'll see the questions, you will see the questions from this part of the chapter. Now basically, what are the angles subtended by chord at any point? Let's discuss this. For example, this is circle 1, circle 2, circle 3 and circle 4. Now in all these circles, let me draw a chord. Okay. So basically this chord, first of all, can subtend 3 different angles. Let me just tell you this thing on this page. If this is a circle, bacha, so and if I draw a chord, so this chord can subtend. What does subtend means? To make. So if I say that this chord is making angles, this chord can make 3 different angles. What are those 3 different angles, bacha? One angle is at the center. Right? First of all, understand the concept that these chords divide the circle into 2 segments. First concept, that the chord divides the circle into 2 different segments. Now in each segment, of course, one will be the major and one will be the minor. The one which have the center in it, of course, will be the major. The one which do not have the center of the circle inside it will be the minor one. So when we talk about the circle which has the center inside of it, the segment which is the major segment, in major segment 2 different angles can be formed. One at the center of the circle and second in the remaining part. Now when I talk about remaining part, it means any part in the remaining part. For example, bacha, this is also remaining part of circle. This is also remaining part of circle. This is also remaining part of circle. This is also remaining part and this is also remaining part of a circle. So all these angles will be considered as the angles in the remaining part of the circle. And the third angle which this chord will make will be in the other subtended segment. Right? So 3 different angles, 2 in the major segment, 1 in the minor segment. Now, these are what the angles subtended by the chord. So when we talk about chord, so one angle will be at the center of the circle, the other part will be in the remaining segments, in the remaining part of the segment, and the third part will be in the minor segment. So these are the 3 different. And in minor segment doesn't only mean one angle, these all angles are part in minor segment. All of them are part in the minor segment. So this is what the angle subtended by the chord at a point means. Now let's start with our theorem number 1. The theorem number 1 says that equal parts, equal chords of a circle subtend equal angles at the center. Now what does that mean? If we have a chord AB and we have another chord CD. This is one chord AB, this is another chord CD, and if I am saying that AB is equivalent to CD, and if I say that AB is equivalent to CD, so what we can say that the angle made by both these chords at the center will also be equal to each other because both the chords are equal to each other. Since both the chords are equal to each other, the angle subtended by them at the center will be equal to each other as well. Now the next thing that we have is, if the angles subtended by the chords of a circle at the center are equal, the chords are equal, the converse of it. In the earlier theorem it was, if chords are equal, angles subtended at the center will be equal. Now this is saying, if the angle is equal, then the chords will also be equal, and that's how we are going to deal with it. The next is, perpendicular from the center of a circle to a chord. Now this is the circle, this is the center. Let's say this is our chord AB. Alright, and from the center, bacha, from the center, if I draw a perpendicular from the center, if I draw a perpendicular means 90 degree to this chord. AB is a chord, O is the center, and from this O, if I draw a perpendicular to this chord AB, this perpendicular, let's say OM, divides this chord into two equal parts, as I can say that AM will be equivalent to BM. So from the center of a circle, if I draw a chord, if I construct a chord, so that particular chord divides the part into two equal parts, right? AM will be equivalent to BM. The next thing that we have is perpendicular from the center of a circle to the chord bisects the chord. The same theorem that if I draw a perpendicular from the center of a circle to the chord, it bisects the chord. Bisects means splits into two different parts. Splits in two equal parts. So bisection means what? To divide it into two equal parts. That is the word bisect means. Now let's move forward to the next theorem. The line drawn through the center of a circle to bisect the chord is perpendicular to the chord. Again, the converse of it. If you have a circle and in this circle, if it says that there is a line which is bisecting the chord, so it will be perpendicular to it. If it is perpendicular, then it bisects. If it is bisecting, then it is perpendicular. Converse, it goes both hands, right? The next that we have is, there is one and only one circle passes through three given collinear points. Now before starting with this, let's discuss if there is 1 point, 2 point and 3 points and 3 non-collinear points. So if I have 1 point like this on a plane, and if I ask you bacha to draw how many circles can you draw? And all of them should pass through this 1 point. So you can say if I have to pass my circle through these points, through this 1 point, so infinitely many circles can be drawn. If I have my circle to be passing this, so infinitely many circles can be drawn like this. So all these circles that I am drawing right now are passing through this one single point. So if I have one single point on my plane, so infinitely many circles can pass through them. Now the question comes, if you have two given points, how many circles can you pass through them? A lot of you will say one. Only one circle can pass, but no. Infinitely many circles can pass through it. How? See. This one is the first circle that passes through it. This one is the second circle that passes through it. This one is the third circle that passes through it. This one is the fourth circle that passes through it. So like this, again, infinitely many circles can pass through two given points that are on the plane. What if I have 3 points? 3 non-collinear. First of all, let's take 3 collinear points. What are collinear points, bacha? The points which are lying on a same straight line. If there are 3 points that lie on a same straight line, these are known as collinear points. If there are 3 collinear points, so no circle can be drawn from these 3 collinear points. But what if, bacha, what if we have 3 non-collinear points? Non-collinear point means one like this, second like this, and third like this. That means all 3 of them are not in a same straight line. So how many circles now can pass through them? So now as we can see that one and only one circle can pass through 3 given non-collinear points. These 3 points are non-collinear. Non-collinear. And only one circle can pass through 3 given non-collinear points. I hope this part is clear. Now, equal chords of a circle are equidistant from the center. If I have a circle and if there are 2 chords that are equal, if I have a circle and if I have 2 chords that are equivalent to each other, so I can say the distance of both of them from the center is also equal. I can say that this part is also equivalent to this part. Clear? The next thing that we have is chords equidistant from the center of a circle are equal. Now again the converse of it, if this distance between them is equal, so the chords are also equal. Next, the question says, if a line intersects two concentric, what are concentric circles, bacha? The circles which have the same center. If you have two or more circles that have the same center, they are termed as concentric circles. Now, we have to prove that AB is equals to CD. The very first thing that we are going to do is a construction. Now, what we are going to do in construction, bacha, we are going to construct OM perpendicular on AB. OM perpendicular on AB, this is our construction. So, let's construct OM and this OM will be perpendicular to AB. Now, the next thing that we have over here is, now see, BC is chord of the smaller circle, AB is chord of a bigger circle. BC is the chord of smaller circle, AB is the chord of bigger circle. If you are not able to see it clearly, let me. If this is the smaller circle, BC is the chord, bacha. Now, if this one is the bigger circle, AB is the chord. So, we are taking both of them as chords of a circle. Now, the next thing, bacha, let's prove this. Now, the very first thing that we have is, if we draw perpendicular from the center of the circle to the chord of a circle, it bisects the chord. So, as we can say that OM is perpendicular to the chord BC, so it divides BC, it bisects BC. That means BM is equals to CM. That means BM is equivalent to CM and this becomes our first equation. Now, the second thing is AC. If we take AD, AD is also the chord for the bigger circle and OM is also perpendicular to it. So, what we can say that OM is perpendicular to AD. And if OM is perpendicular to AD, then we can say that AM is equals to DM. AM is equivalent to DM and this becomes our second equation. Now, we have to do nothing, just subtract the first equation from the second equation. When we subtract the first equation from the second equation, we get AM minus BM is equivalent to DM minus CM. Now, see, AM minus BM is AB, DM minus CM is CD. So, what we get from here, that AB is equivalent to CD and this is what we had to prove in the very first part. So, this is how we prove it, this is how we do it and I hope that this question is clear with everyone. Angle subtended by an arc of a circle is same as chord. So, in some questions, you might not be able to see a direct chord and the angle subtended by it. No, you will just be seeing a floating arc, starting point, center, ending point. So, this is also the angle at the center and this is also the angle in the remaining part of the segment. It is just that you haven't joined this AB right now. So, if you call it a chord or an arc, nothing changes by that. Alright, I hope you are not confused. The angle subtended by an arc at the center is double the angle subtended by it at any point in the remaining part of the circle. Now, what does this mean? Let's understand. We have a circle. As I have already told you that this is arc and if I imaginarily join it, basically segments only, right? The minor one, the major one. So, basically I have already told you that one angle is formed at the center, the other angle is formed in the remaining part of the segment. Now, there is a relationship between this angle and this angle. If this angle is 100 degree, this angle will be 50 degree, that means half of it. So, whatever angle the arc or the chord is making at the center, bacha, that angle will always and always be double from what it is making in the remaining part of the segment. So, if this is 100 degree, this one is 50 degrees. As simple as that. So, this is how you are going to deal with it. If this is 100, this is 50, that's it. Getting the point? If for example, this is 60, this is 30. If this is 20, this is 40. It goes both ways, right? I hope this part is clear with everyone. The sum of either pair of opposite angles in a cyclic quadrilateral is 180. Now, first of all, let us understand what a cyclic quadrilateral is. So, any quadrilateral is a four-sided figure, bacha. Yes. So if we have a four-sided figure and all the four vertices of the quadrilateral touches the circumference of a circle, this is known as a cyclic quadrilateral. And what is the property of cyclic quadrilateral? That the opposite angles are supplementary. That means if this is angle A, this is angle B, this is angle C and this is angle D. So I can say that angle A plus angle C is equals to 180 degree. Angle B plus angle D is also equals to 180 degree. So this angle plus this angle and this angle plus this angle is equivalent to 180 degree. By what it means? Clear with everyone? I hope this is clear. Now let's see a question like this. So in this it is saying in the figure below A, B and C are 3 points on the circle with center O such that BOC is 30, AOB is 60, D is point on the circle other than the arc ABC. Find ADC angle. We have to find out this angle. So basically, bacha, what do you have to see in this? There is an arc, there is an angle at the center and there is angle in the remaining part of the circle. So this is the picture on a whole basis that you have to see. Now how to see? First of all, how to write it down? So angle AOC. How can you write angle AOC? Angle AOC is angle AOB plus angle BOC. So angle AOC bacha will be equivalent to 60 plus 30 degree. So from here we get that angle AOC is equivalent to 90 degree. From here what we come around with, that angle AOC is equivalent to 90 degree. Now the next thing that we have is, now see, understand the concept. Arc, angle at the center, angle in the remaining part of the segment, that is half of it. So what we can say, that angle AOC, half of angle AOC is equivalent to angle ADC. Angle at the center is double than angle in remaining part of segment. You have to write this whole statement every time you do this question, right? So basically half of 90 is equivalent to angle ADC beta. So from here we can say that angle ADC is equivalent to 45 degree. Angle ADC is equivalent to 45 degree. I hope that this question is clear with all, right? In any question, bacha, if you face any trouble, feel free to comment it down and ask me, right? Okay. Now let's move forward. A chord of a circle is equal to the radius of a circle. Let's draw it. So we have a circle, bacha, first of all. Alright, we have a circle. Now what is saying that there is a chord in this circle and it is equivalent to the radius. Let's say this is the chord of the circle, that is AB. And it is equivalent to the radius of circle. Alright. Find the angles obtained by the chord at a point on the minor arc and also in the major arc. Now first of all, bacha, let us join. Okay, let us join this. This will be at the center. This will be at the center. And this will be in the major arc. Okay, this one is at the center, that one is in the major arc and this one is in the minor arc. So let's say this is X, this is Y. We have to find both of them and this is the center O. The very first thing is OA and OB are the radii of circle. See, OA is the radius of the circle. OB is also the radius of the circle and it is given in the question that AB is also equivalent to the size of the radius. So what we can say in this question is OA is equals to OB is equivalent to AB. So from here we can say that triangle AOB is equivalent to a equilateral triangle. Since all the sides of triangle ABC are equal, AOB is equal, so we can say that AOB is an equilateral triangle. If AOB is equilateral triangle, that means all the angles are 60 degree. That means angle AOB is also 60 degree. So we can say that angle AOB is equivalent to 60 degree. Why? Because it is an equilateral triangle. Now, since it is an equilateral triangle, bacha, so we can say AOB, let's say this part is C and this is D. Now, as we can say that if AOB is 60, so ACB will be. So, we can say that half of angle AOB will be equivalent to angle ACB because it is angle at the center and ACB is the angle in the remaining part of the segment. Right? So, half of AOB means half of 60 degree is equivalent to angle ACB. So, angle ACB will be equivalent to 30 degree. So, angle ACB will be equivalent to it will be equal to 30 degree. Now, bacha, now we are talking about angle Y. In the minor, this is the major one, this is the minor one. One thing which you can clearly see in this figure is this AD, this, and this forms a cyclic quadrilateral. A, D, B, C forms a cyclic quadrilateral. So, what we are going to write down, the very first thing is that A, D, B, C forms a cyclic quadrilateral. Now, if it forms a cyclic quadrilateral, we can say that angle C plus angle D is equivalent to 180 degree as they are supplementary. So, that means 30 degree plus angle D is equals to 180, and from here we get the angle D as 150 degree, or we can say 180 degree minus 30 degree, that is 150 degree. So, from here we can say that angle D is 150 degrees. So, this is how you do the questions. This is how you solve them up, and I hope that the solving is absolutely clear with everyone. The next thing that we have is, in this we have to find out OPR. Now, what is OPR? This smaller one. Now, first of all, bacha, as we can see that PQR is the angle in the segment, and POR, this angle is the angle at the center. So, what we can say that angle POR is equivalent to double angle PQR. So, angle POR, bacha, will be equivalent to twice into 100 degree. So, angle POR will be equals to 200 degree, the very first thing that we have got in this question. That POR is 200 degree. Now, listen to this thing very carefully. If this is 200 degree, so this remaining part, we know that angle around the point is 360. If this part is 200, so this POR will be, the upper POR will be 360 minus 200. So, we can say that remaining part of POR, or this is, if this is reflex of POR, so we can say angle POR now will be equivalent to 360 degree minus 200 degree. So, we can say that angle POR is equivalent to 160 degree. Now, this is the second thing that we have got in this question. Now, the third part is in triangle POR. Now, this triangle looks very, very small. This triangle goes like this, kind of like this and this, if I draw it more elaboratedly. Okay, so this angle is 160, bacha. This side is equal to this side because both of them are the radii of the circle. So, what we can say in this, after this we can say that in triangle POR, the very first thing is OP is equals to OR because they are the radii of the same circle. Yes, the next we can say is angle POR is equals to 180, before this we can say that if OP is equals to OR, so we can say OPR, angle OPR is equals to angle ORP because angles opposite to equal sides are also equal. So, angle opposite to equal sides, bacha, are also equal. So, if OPR is equals to ORP, let's say both of them being equal to X, so we can say the angle POR plus angle OPR plus angle ORP will be equal to 180 degree because it's the angle sum property of triangle. Because it is the angle sum property of the triangle. Now, POR is 160 degree, OPR is X, ORP is also X equals to 180. 2X is equivalent to 20 degree bacha, and from here we get the value of X as 10 degree. We can say X is equivalent to 10, or we can say this is angle OPR which we had to find out. So this is how we deal with the question, and I hope that each and everything written on the board is absolutely clear with you people. Let's move forward to the next question. Now we have to find out angle BDC, that means this angle. Right, now this is chord. Angle in the same segments are equal. Now this is one more thing. As we have seen, there is one angle at the center, angle in the remaining segments, and all the angles in the remaining segments are equal to each other. Now first of all, in triangle ABC, when we talk about triangle ABC, we can say angle ABC plus angle BCA plus angle CAB will be equal to 180 degree angle sum property of the triangle. Now ABC angle is 69 degree, BCA is 31 degree, and angle CAB is unknown to us, that is equivalent to 180 degree. Right, I hope this is clear with everyone. So 9 plus 1 is 10, and then we have it as 100, right? 69 plus 31 is 100 plus angle CAB is equivalent to 180 degree. So from here we get angle CAB is equivalent to 180 degrees minus 100 degree, which is equivalent to 80 degree. So angle CAB came out as equal to 80 degrees. Now if CAB is equals to 80 degree, what we can say that angle CAB will be equals to angle BDC because they are angles in same segment. Because they are angle in the same segment. So at the end we can say that angle BDC is equivalent to 80 degree as well. So I hope how to attempt the question, how to do the questions, all these things are absolutely clear with everyone, right? Now let's move forward to the last question. Now in this question, we have to find out BAC, that means this particular angle. Either you can find out this angle directly, or you can find out this angle and both of them will be equivalent. So let's see which angle we can find out. First of all, we can see that angle BEC is 130. If this is 130, bacha, this will be 50 degree because they are forming linear pair. They are angles on a same straight line, right? So very first thing that we can say, angle BEC beta plus angle CED will be equivalent to 180 degree, and what will be the reason? Because it is linear pair. Because it is forming linear pair. The very first thing. So if BAC is given to you as 130 degree plus CED is unknown is equals to 180 degree. So from here we can get angle CED as 50 degree. So the very first thing that we have gotten in this question is that this angle is 50 degree, that is angle CED is 50 degree. Now the next part that we have is, if this CED, now in triangle CED, if we add 50 plus 20, we have 50 degree. We have one angle as 20 degree and the other unknown angle as CDE. All of them will be equal to 180. So from here we get angle CED as 180 minus 70, 110 degree. Now at the end we can say that angle CED, or we can say angle CDE, is equals to angle CDB, and which is equals to angle CAB or BEC, because angles in the same segment. So angle CAB from here comes out as 110 degree. As simple as that. So this is how you do the questions, bacha, and this was all from the chapter circles. I hope that this thing is absolutely clear with you people and you have no doubts in this. If you have any doubt in any of the question, bacha, feel free to comment down. So I'll answer them for sure. So till then, take care, have a great time ahead. I'll see you in the very next class with yet another one shot of next chapter. So till then, take care, have a great time ahead. Thank you so much everyone. Bye-bye.